Hey everyone, so today we're going to be talking about arrays and loops. I've prepared a few code examples on .NET Fiddle that I'm going to go through and explain to you line by line. We're going to start off with arrays because they're a little bit easier. An array is nothing but a single variable that can contain multiple values, whereas a variable of type int can contain one integer. When you put the two brackets here after the type, it turns into an int array. So that's what you can read that as. So instead of just typing int, you type int with the brackets after it, and that implies that it's an array and can contain multiple values. So everything else is just like normal. You just specify the name of the variable, and this is just a simple array variable declaration. The only thing has changed is the type. It's instead of a single primitive type, it's a type which can contain multiple values, or an array. We say primitive array because as soon as we get into object-oriented programming, we'll have more complex types than int, string, bool, and double. On line 3, the difference between a normal variable and an array is instead of going directly to the value assignment after you declare it, there does need to be this intermediary step where you allocate memory for it. The reason is, in the variable declaration, you can see it doesn't say how many integers there are in the array. The reason for this is they want to give you the power to be able to take that variable list of numbers and make the array as big as you want. So you can start off with 3, you can change your mind later and destroy the array and recreate it as a bigger or smaller number. If you didn't do that, I guess in some older languages, like right in the variable declaration, you would say like, I'm declaring a list of array of 10 integers. But by doing that in the declaration, you've basically put yourself in a situation where you can't change the size of the array during runtime while the program is running. You can only set it while you're writing your code, which is at compile time. We say it's a compile time. So that's when it's compiling your code, not when it's running the program. This actually allocates enough memory for 3 integers while the program is running. So you can actually come around later and do this line of code again with a bigger number, and it'll destroy the array and all the values in it, but it will make a larger array after the fact. So that's why we have this word dynamic, because it happens during runtime while the program is running, not at compile time. So once you have this, you basically have a situation where now instead of just one value, you have 3. And the way you access each of the 3 is by indexing the array variable. Everything in programming is always 0-based. So instead of the first position and the second position and the third position, which these are, you just have to index them with 0, 1, and 2. So the first integer, the second integer, the third integer. So looking at the array is the same as setting it. You just refer to the certain index. So as you can see, we've tried to put in 5, 8, and 13 in the 3 positions of the array. And when we try to print them out, you see down here in the output 5, 8, and 13. The second example here is the same exact example. The only difference is I've changed the type. So here, instead of an array of integers, we have an array of strings. So it's the same thing. We have 3 strings. We set them with a value assignment at index 1, 2, and 3, which are actually the numbers 0, 1, and 2. And then we write those same exact values out. This is a string. This is a string. This is a string. This is an integer. This is an integer. This is an integer. All right. So a loop, or sometimes we call a repeater, or sometimes we call an iterator, boils down to one basic concept, which is repeating the same line of code over and over and over again. So you really have to memorize the format of the for loop. Like I told you guys in class pretty much, if somebody tells me I have to write a for loop without even knowing what it does, I automatically write this. For int I equals 0, I can't type well when people are watching. There's too much pressure. So this is pretty much the format of the for loop, no matter what. The only thing you do is you change this number here to be the number of times that you're iterating. As far as like the whole 3 components of the for loop, I will explain them because actually you can just do this. That is a valid for loop. So there's something that goes there, there's something that goes there, and something that goes there. So you don't need to, but this is the basic structure of the for loop. And as we'll see in the couple of examples after, it doesn't always have to be this way. But as briefly as possible, what these 3 components do is this first space is meant to give you a place to declare a temporary local variable just for the scope of the for loop. And that variable, its utility is to tell you which iteration you're on. So combine that with the last component. The last component is something that happens at the end of each iteration. So with the first component, you're saying, before this for loop even starts, I want to declare an integer called I and initialize it to 0. And by the way, this is going to go away as soon as the for loop is over, because it exists in the context of this begin and this end. And with the last component, the third component, you're saying, and by the way, every time I loop, or every time I hit the end, to be exact, I want to increment I by 1. So in essence, what those 2 combined are saying is I want to go I equals 1, then do it again for I equals 0, then do it again for I equals 1, then do it again for I equals 2, and then do it again for I equals 3, and so on and so forth. Now that would go on forever if it wasn't for the middle condition. The middle statement, which is a condition. So this middle component of the for loop has to be a Boolean value, and that tells it when to stop. So that you can read this as keep going while I is less than 10. And that's why it stops when it gets to 9, because 10 is not less than 10, therefore this becomes false, therefore it continues on in the program. So you're stuck in this loop until this condition is satisfied. So it's declare I equals 0, keep going while that variable I just declared is less than 10, and after each iteration increment it by 1. That's the basic format, but in essence you really don't have to do those as long as you definitely need a condition there in that second part to say when to stop looping. The first thing is there the first and the last components are there to give you whatever control you need over the loop. But the middle component is essential because you have to stop looping at some point. Well, you don't have to, but you should. So as you can see in this first example, I'm just saying, once again, if you just memorize that format for int I equals 0, I is less than 10, I plus plus, begin, end, any line of code you write in that will happen this number of times. So you can see it's typing out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, just like I said. So this next one is kind of tricky because you notice instead of going I plus plus at each iteration, I'm going I minus minus. So I'm saying start with I equals 9 and keep going as long as I is positive, 0 or greater. I guess, is 0 positive? I'm so bad at math, I don't know. Keep going while I is greater than or equal to 0. And at each iteration, I want to make I smaller. So this should say 9, and then it'll say like, oh, is 9 greater than 0? Yes. So keep going. And now make 9 8. So it'll keep doing that. It'll come back here and it'll be like, is 8 greater than or equal to 0? Yes. Then make it 7. So it should print them out in reverse order this time if I save it and I run it. And now it says 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. So that's not that bad. Comment that, move this down to here. Next example, This for loop is much more interesting because I combine conditional logic in there. So this is a normal loop. I'm actually starting at 1 for whatever reason. I'm saying start at 1, keep going while you're less than or equal to 20, and this is very common. Almost every for loop is going to be I++. The purpose of I is basically to tell you which iteration you're on. I'm on the first iteration, I'm on the second iteration, I'm on the third iteration, I'm on the fourth iteration. So what am I doing with this loop? It seems that I'm doing something 20 times, but it just so happens that I have a condition on the thing that I want to do. So I'm using the modulo operator. So just explain this modulo operator really quick for those of you who are not that great at math like me. Modulo is a remainder operator after integer division. So this pretty much sums it up right here. If you perform integer division on 27 divided by 9, well, 9 divides into 27 perfectly. So 3 times 9 is 27, therefore 27 divided by 9 equals 3. And since there's no remainder, and that's perfect, 27 mod 9 equals 0. So this number implies the result of the modulo operator. It means that I attempted to divide the first number by the second number, and the remainder that was left over is what I get. So 27 mod 9 equals 0. Here's another example that will illuminate it a little bit more. 31 divided by 9 is the same in integer division as 27 divided by 9, because 3 times 9 is 27, and it's going to just drop off the last 4 numbers as the remainder, because that's how integer division performs. However, that number 4, that remainder of 4, is still interesting if we use the modulo operator. So 31 mod 9 means, okay, 9 times 27, or sorry, 9 times 3 is 27, but we still have this 4 left over. So that's what mod gives you. It gives you the remainder after integer division. The reason that's useful for what I'm doing here is, as you can see, if you mod something by 2, you get a very specific result. Any even number mod 2 gives you 0. So 2 divided by 2 is this perfect 1 with no remainder, therefore you have no remainder, and 2 mod 2 is 0. But if you take an odd number, 2 goes into 3 once, yes, same as 2 divided by 2, but there's a remainder of 1. And as you can see, you can keep repeating this forever and it'll always be the same. 2 goes into 8 4 times perfectly, 2 goes into 9 4 times as well, but there's a remainder of 1. So modulo is often used as a way to see if a number is even or odd. And the way that that comes out is you say if the number that I'm looking at modulo 2 is equal to 0, that means it's even. So in this case, I'm going from I equals 1 to I equals 20 for only the even numbers I want to print them out. So let's try to save that, and it's going to run, I hope. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So there's another example of looping over stuff with different examples, different results. Uncomment the last one. So this last one seems to be a double loop. Ooh, that's fun. So by convention, we usually use I and J for a nested loop. If we're inside of here, we can't reuse I. We can't redeclare a variable named I because we've already declared it in the current scope. And a couple of you have asked this, and I've answered. A smaller scope, something inside of a larger scope, does have access to anything in the larger scope. So if I had that int x, it would be available inside of this loop as well as inside of this loop, but it would not be available later on, say, down here. I wouldn't be able to, say x plus 5. It wouldn't know what this is because that is defined in the smaller scope. Both the form of your brackets and the indentation can help you read this easier, because you can see here that if you move straight up, the x is indented once, and that implies that it's in a smaller scope. Or you can just read the brackets. Anything inside of these brackets goes away once the end is reached. So that's the reason for this variable being named j. So what does it mean to put a loop inside of another loop? Well, we can test this just by commenting out the outer loop for a second. So what does this do? I'll just say 0 for now. I accidentally commented out the 0 and then referred to the, commented out the I and then referred to the I. So this is printing out 8 times as we expect. It's just a normal for loop from 0 to 7 because that is saying go from start at 0 and go while j is less than 8. So we have 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7 because we printed out 0 and j. So that makes sense. So that's what this does. That thing that I have highlighted right there, that's what that does. It prints out a 0 followed by the index. Now if I put it inside of if I put the loop itself inside of another loop, it stands the same. So the whole idea of the loop holds the same. Now the outer loop, the I loop, says do everything inside of me 8 times. So the question is, okay, what do you want me to do 8 times? And the answer is this. I want you to do this loop 8 times. It says loop and then do a carriage return. Loop and then do a carriage return. So it's going to do that 8 times. But this loop in and of itself does 8 things. So since it's going to do these 8 things 8 times, we should see 64 prints. Now there's this carriage return here, or end of line, only happens 8 times because it's not inside of the double loop, it's inside of the for loop. So we should see, since this after each 8 prints of the j or of the j loop, we write a line and go down to the next line, and we should see 8 lines of doing 8 things, which amounts to 64 things. So let's save that. And as we can see, it does print out 64 things. The only problem is that we left this as a 0. So effectively, and this is again something you kind of memorize, anytime that you have an outer loop and an inner loop and you call them I and j, so exactly like you see it here, for I equals 0 while I is less than 8. For j equals 0, j is less than 8 inside of the I loop. You set yourself up to be able to write one line of code that happens I times j times. So if I was 4 and j was 10, it would happen 40 times. And the way you index it would be referring to I and j, because I is changing and j is changing. So for I equals 1, it's going to iterate j from 0 to 8. For I equals 2, it's going to iterate j equals 0 to 8. For I equals 3, it's going to iterate j from 0 to 8. For I equals 4, it's going to iterate j from 0 to 8. So now that I have it back to where it belongs, you're going to see it does every single permutation of I and j. So this line right here, this first line that it printed out, is just the first iteration of the outermost for loop, int I equals 0. Notice it says 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. It keeps saying 0 every time. It's because I is always 0, because it's all in the first iteration of the I loop. This is the second iteration of the I loop. So now I equals 1. 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Notice 1 every time. That's because we're in the second iteration of the I loop, and I equals 1. So that's a little bit harder to grasp, and we don't really do that in our assignments or quizzes or tests or anything, but I did think that I should show you because double loops are pretty common in a lot of code in the industry. So here's the result of all of that, all those examples. So that one took a little bit of time to go over. Excuse me. And now I'll talk about while loops really quick. I'm not going to spend too long on it. It's pretty easy to understand. A while loop simply takes a condition and keeps going until the condition is false. So what I've done here is I've established an input of 1 because I'm going to keep asking the user a question. And once they give a wrong answer, an indication that isn't what I expected, I'm going to stop. So this says, as long as the user input a positive number, now I'm sure 0 is not a positive number. I'm all of a sudden better at math. System console, so it asks the user for a number. It asks the user to type 0 to quit. In actuality, anything, even a negative number would quit, but it says type 0 to quit. So it reads a number from the user, it adds it to the total. So this is going to just keep adding until I eventually type in a number that's 0 or less, and then it's going to stop. So I say 5, the total is 5, 7, the total is 12, 8, the total is 25, the total is 25, and now I'm going to say -6, and it's going to quit. So the final amount is 19. All right, so hopefully this is pretty self-explanatory. There's really nothing more to it other than the code inside of the while loop keeps iterating until the condition that controls it is false. So this is more, instead of doing something a very specific number of times, this is more useful for, you don't really know how many times you're going to do it, and you just want to do the thing until a certain condition is met. So that one's good. And then finally, we're going to combine the two topics of loops and arrays in this very beautiful code that shows you just how great everything is. So we start off with a simple string of names. It can hold 5 names. Now, notice instead of saying name sub 0 equals this, name sub 1 equals that, name sub 2 equals, I don't want to write that because it's tedious. What if there's 100 or 1,000 or 100,000 elements in the array? That would get very tedious. So the loop gives us the power to, combined with the array, perform a single option on every element of the array. So I say start I equals 0 because that's the first position in the array. I want to keep going until I've reached the last element of the array, which is array sub 4. So that's why while I is less than the length of the array. The length of the array in this case would be 5. We don't want to access I position 5 because that would crash. There is no position 5. 4 is the last position. So you always want to say I is less than the length of the array, not less than or equal to, or else the last attempt will crash. It will say invalid access to invalid memory access or something like that. So it's trying to, or index out of bounds, I think is what it says. So if you see something like that, it means you're trying to access an index or a position in the array that does not exist. So once again, once you have your array and you set your loop up like that, exactly like that, you can write anything you want in here and it'll happen for every element of the array. So I'm saying I want to enter the name of the array plus 1 because it's 0 based and I don't want it to say 0, 1, 2, 3, 4, 5, or 0, 1, 2, 3, 4. And then I'm going to ask the user to type in the name and it's going to store it in the array. So it's going to do this 5 times. So before I even go on to the next part, it says, enter name 1, let's say Donnie. It says enter name 2, let's say Michael, that's my brother. Enter name 3, Alana, that's my sister. Name 4, I'll just say dad, and mom. So you're already going to see what it does in this next part, which is 1 line of code. All of a sudden, there's 5 more print lines. Where did those come from? Those print lines came from this statement right here. The for each loop, it does the same thing the for loop does, except 1, it reads better, and 2, it implies that you don't need the index. So I don't need the I. I never need to say, like, here's the iteration I'm on with a number. It just says, hey, there's this list, there's this array, it's called names, and it's got a bunch of strings in it. So for each string in it, and you can call this anything, you can call it, X for all I care. This is just a variable declaration. It says there's this collection, this array, has a bunch of strings in it, and for each one of them, I'm going to refer to it as that as we go through. And that reference will be the current string. So basically, for each string in these strings, this is the current string, and do that. So it just does this line of code, system console write line name is in the list for every single string in the strings, or semantically every name in names. And that is all. So I'm going to do another video after this because we've reached the halfway point in the course, and I'm going to kind of bring it all together with everything we've learned. Loops and arrays are going to be essential in this next video, in this next program that I show you. It's going to be complicated, but it is going to demonstrate kind of a more pragmatic and practical use of loops and arrays. So if you feel like you're ready for it, at some point, whenever you feel like you have a good handle on all the topics in declarative programming in the first half of the course, please move on to that and take a look and see what you think. All right, thank you.